Okay, so let's talk about refraction through curved surfaces and lenses. The way we talked in mirrors and we followed the process, it would be exactly same. There will be small difference, and that you should try to learn separately. Otherwise, follow the steps which you did on mirror. Same thing we have to do. So we will take example of a point object and a curved surface. Okay. So let's take a curved surface which is like a convex. Okay. Something like this. This is your P. Alright. This is your C. And this is your normal. Alright. This is point object O. Rays falling, and it's difficult to draw a straight line, but you can practice. Okay, and then it. Okay, I could manage to do it. C I this dot shows that this is a denser material. Alright, let's draw perpendicular here. This is your P, this is your M. So it's a convex shape curved surface, okay, and object is on the left side. Rays are going like this, okay. So we need to take two rays as usual to identify point of image, okay. So first ray we took, like it starts from here, it falls, it hits at that point, and this is a normal because a line passing from a curved surface through center of curvature would be always a normal, right? So that is why we connected this line to that point, and it would be always normal. You know that, right? All radius of the circle are normals at that point. Because ray of light is going from rarer, this is rare. Rarer means it could be air and it could be a glass, right? Or denser. So it would be bending towards normal. This angle we call it I, angle of incidence. This angle we call an angle of refraction. So R would be less, and that is why it would be like converging toward, I mean it would be bending towards the principal axis. Okay, so now on similar way we will just use trigonometry and try to find relation between U and V. Alright, but the difference would be in case of mirrors, our I was equal to R, but here, because we some time back we learned about refraction, here we have relation sin I divided by sin R equal to N2 by N1. That is N1 sin I equal to N2 sin R. So we will use this relation as a base, okay. In mirrors we used I equal to R. Here we will use N1 sin I equal to N2 sin R. That is the difference. So you need to remember it. Now let's use some geometry here. I would be exterior angle for triangle O, let's say this is your A, OAC. Let's name these angles. This is alpha, and I think you should use these terms all the time you practice. You don't need to practice more than 2 times. Alpha angle which is being formed from object, right? Alpha. This is your going to be beta for image, and this one, which is a normal at point A going through C, is gamma. Okay, so I would be exterior angle of triangle OAC, which says I equal to alpha plus gamma, because it would be sum of these two angles. It is exterior angle. In second case, we will see that gamma is exterior angle of triangle ACI. So gamma equal to R plus beta. I am writing it here so that I have enough space to complete whole derivation on this much space. So very simple. We wrote I equal to alpha plus gamma and gamma equal to R plus beta. And now we know that N1 sin I would be equal to N2 sin R. That is nothing but Snell's law, or we studied law of refraction through plane surface. So at this point, this would act like a plane surface, because this would be a normal at that particular point. Now what we will assume, and that is caveat, that for small angles, if the aperture of this convex shape is less, then these I and R would be very small. If you think like a small lens, not lens, sorry, this kind of shape, small, this I and R would be very small, maybe 5 degrees, you know. So in that range, we can assume sin I equal to I, right, and sin R equal to R, if you are measuring it in radians. Again, I go back to mirrors. We did similar thing. We assumed that curvature is small, so angle I, or it is equal to alpha. There we used alpha equal to tan alpha, right? So we will say sin I. So now it becomes N1 I equal to N2 R. Now our objective should be to replace these I and R in terms of alpha, beta, gamma. This is a milestone, and whenever you try to revise this derivation, you have to remember two or three milestones, so that you try to reach there, and and story before that and story after that, you can do it on your own, just looking at diagram. So you need to remember this diagram, and then you need to remember first part I told, this applies Snell's law, and then assumes aperture is small. Okay. Now we will see I equal to here alpha plus gamma. So we will say N1 into alpha plus gamma equal to, here R would be gamma minus beta. So I think I should better write it alpha gamma plus alpha and N2 multiplied by gamma minus beta. It resembles, right? It's easy to remember. Gamma plus alpha, gamma minus beta. We can take it from these two equations. Okay. Now we will again use the same geometry formula or trigonometry. When all these angles are small, we can write, let me first let's simplify, then we will say, we can write tan gamma equal to tan gamma, alpha equal to tan alpha, similar to what we did in mirrors. That's a standard thing, because our objective is to have a correlation between UV and that is possible if we use this tan alpha equal to h by this height divided by UVF, and h would be cancelled. Okay, now let's go with this N1 gamma, right? Just to save space, what I would do, I will write N1 alpha. In one step I am writing plus N2 beta equal to, I will take this N1 gamma right side, N2 minus N1 gamma. Alright, now I'm saying that this alpha is replaced by tan alpha and beta, so okay, let me write, it's not that big, tan alpha plus N2 tan beta equal to N2 minus N1 tan gamma. Tan alpha is nothing but, if this height is h divided by OM, and again for a small aperture M and pole would be pretty much close to each other, so we can say this is U. Okay, so we can say h divided by OP, which is nothing but U, and similar to what we did earlier, when these are all magnitudes, but we have to put sign, right? So that when in numericals we put sign one more time, it becomes a magnitude. So we will say plus h divided by minus U. This is on the y direction above the principal axis, it should be plus. So N1 into plus h divided by minus U plus N2 tan beta would be h divided by, because we measured this U in the opposite direction of ray, so that's why it was minus U, and now we will say N2 multiplied by tan beta would be h divided by V, so h divided by V, and gamma would be h N2 minus N1 tan gamma would be h divided by this PC. PC is nothing but R, which is again positive. Okay, so with this logic we have now h here h would be cancelled, and we will have N2 by V minus N1 by U equal to N2 minus N1 divided by R. Is it difficult? Probably no. If you remember that since you have to find relation between VU and radius of curvature, right? So you have to use this alpha beta gamma and convert it to tan alpha tan beta gamma and put the values in those magnitudes terms, right? Perpendicular divided by base, right? And before that, so that was one caveat, and every place you have to remember this is a small curvature. Okay, and the first step would be use trigonometry where exterior angle I and find a relation between I and alpha beta gamma and R alpha beta gamma, right? Use trigonometry, exterior angle property, try to put value of I from those two equations, right, in N1 sin I equal to N2 sin R, which is Snell's law. So 2 to 3 in between milestones, if you remember, and if you remember this diagram, it's not that difficult. Okay, so we reach to this formula which I have written in the top, and if you divide N2 by N1, then it becomes N2 by N1 is nothing but refractive index of this material with respect to this. If it is air, then N2 becomes refractive index of this. So this whole formula becomes N2 by N1, which is nothing but N by V, minus this becomes 1, and this becomes N minus 1 divided by R. Okay, so whatever we learned for curved surface, let's use it and try to derive formula for lenses, which is relation between V, U and F. The formula is very similar what we have in mirror, except here you have minus sign, like 1 plus V minus 1 by U equal to 1 by F. Okay, so a lens is made of two curved surfaces. So let's take example of a convex lens, a thin convex lens. Okay, this is T, and take example of a point object. Again we will take example of a point object. Let's say this is your F, this is F dash, and we took example like this. It will be going something like this, and then it will be going something. This is your C, this is your U. So if you extend this first line, maybe this is your I dash and this is UI. So just to explain, there will be a refraction at first curved surface, which is a convex surface, and that ray will be going like this, and then there would be a second refraction which will further bend that ray down towards principal axis. So final image would be formed at I, but if you imagine this second surface is not there, then you extend this ray straight, and the final intermediate image could be at I dash if the second surface was not there. Okay, so here let's take the final image is V, which we have to find relation between V and U, and the I dash is V dash. Okay, so what we will do, we will apply this formula, curved surface formula, first at convex surface and then at concave surface. So for first refraction, formula would be N by V minus 1 by U. Okay, here let's say this is your N1, this is your N2, and again this is your N1. Alright, so now N by V, or you can say N2 by V minus N1 by U. Okay, here we will write V as a V dash because we are just considering the first refraction, equal to N2 minus N1 divided by R1. R1 is radius of curvature of this first surface. Alright, now for second curved surface, your V dash, which is like image formed by first surface, right? will become u for the second surface. So now formula will be n1, because here the ray is going from n2 to n1. So we have to write n1 divided by final v, because then final image is formed at distance v, minus we have to write n2 and divided by v dash equal to, here we would write n1 minus n2 divided by r2. So if we sum these two form equations, then these two would be cancelled, and now it would become n1 divided by v minus n1 divided by u equal to n2 minus n1 divided by r2 minus r. If you divide it by n1, right, so then it becomes 1 minus v, 1 minus u equal to n2 divided by n1. Okay, so this becomes n2 by n1 is nothing but refractive index of this material with respect to first material. If it is air, it is just n2 because n1 will be equal to 1. Let's say this is not air, then we will write here only n minus 1 divided by r2 minus r1. Okay, so we got the same formula, n minus 1 by r1 minus r2. So now you take example when u is at infinity, the object has been put at infinity, then 1 by v would be n1 minus 1 by r1 minus 1 by r2, right? That would be your 1 by v. Okay, and that is a fixed quantity because our radius of curvatures are same, refractive index would be same. So that is why we say that whenever the object is at infinity, the image position would be fixed, and that is called the focal point of convex lens. Alright, so we can say that this portion n1 minus 1 divided by 1 by r1 minus r2 can be termed as a f, which is focal length, and then our formula becomes here whatever we have derived, right, equal to 1 by f. Alright, okay, so what we did here, just to recap so that you remember, we did nothing, just we did application of formula of curved surface 2 times, one at this, another at this, and image formed by first surface becomes object for second surface, and final image position becomes the image for the second surface. So that's what we did, and we just summed it up, and both got cancelled. So very straightforward. Now what we will do here, again we took example of a point object. If you remember, in mirrors we always take example of a linear object because that gives more idea. There's nothing like a point object, right? So let's take example of a linear object and then prove same formula for the lens. This formula is called 1 by V minus 1 by U equal to 1 by F, lens maker's formula, where 1 by F equal to n minus 1 divided by 1 minus 1 divided by R1 minus 1 by R2. Because using this formula, radius of curvatures, lens makers calculate focal length, which they use for specs or anything else, spectacles, right? Okay, so again, we missed there to mention that when we say a thin lens, then T is very small, because U for the second surface was actually V dash minus T, right? But because it is a thin lens, so we can say that it is V dash equal to T equal to 0, so V and U are same. Okay, here again we will take this linear object which is somewhere at the first focal before second focal point, and then as you remember, to identify position of image we take two rays. So one ray would be going from center of curvature, another ray would be, and then it will go, let's say like this, and they are intersecting somewhere here. This is your F. Alright, so one ray, this is your C. Any ray passing through C, it goes straight, okay, and one ray parallel to principal axis, it has to go from focal point F, okay, and they cut at some point. So now this would be your U, okay, this would be your V, F we know, this length would be your F. So what we need to do here, we need to imagine two triangles, okay. We need to, let's say this is your A B and this is your A dash B dash. So similar to what we discussed in mirrors, we will have similar triangles and we will use property of similar triangles. So first two triangles which we are going to take are triangle ABC and will be similar to triangle C A dash B dash and C, okay. And what it says, let's say this is point M, okay. So AB divided by BC equal to A dash B dash divided by B dash C, okay. Make a note of it. We always take two triangles, one formed by second ray, or you can say first ray, which goes through C. And similarly we did in mirrors also, that the ray which passes through C, that what two triangles it's forming, like this and this, okay. And second set of triangles, we take the ray which hits lens or mirror parallel to principal axis and then refracts or reflects. So another triangle would be this one and this one, which we say, let's say I will write here, M, C, F are similar triangle to F, A dash, B dash and F. Why I am mentioning that? Because people get confused, which two triangles we have to take similar as a similar triangle. And if you remember these two, what I said, triangles formed by first ray, which is like this, triangles formed by second ray after refraction. So this one and this one. So one more time we will have AB, here we will have MC, this MC divided by CF equal to A dash B dash divided by FB dash. Because AB and MC would be same, so AB divided by BC would be equal to MC divided by CF. So what we can say here, A dash B dash, right? A dash B dash, we can take A dash B dash here and BC and CF on other side. So we can say AB divided by A dash B dash from first equation and AB, which is MC, divided by A dash from the second equation. So we will say BC divided by B dash C, BC divided by B dash C, okay, equal to, from second equation, CF divided by FB. Now we will just put the values because these are magnitudes, right? So we will put the values with sign. BC is nothing but U, but sign of the U would be negative. Reason, it's opposite direction of the ray. It is minus U. And B dash C would be V with the positive sign equal to CF. CF is your nothing but focal length, but it would be positive. So F, and last is FB. So FB is nothing, V minus FB, right? V minus F, and V would be also positive and F would be also positive. So it would become V minus F because it is V minus CF and CF is F. So if you do cross multiplication, you will find it will be like VF, UF will come UF minus VF equal to UV. Okay, divide by UVF, whole equation, it gives 1 by V, 1 by U equal to 1 by F. Alright, so here what would be caveats? That we are assuming first thing it's a thin lens. That is reason we are not considering this width of this lens. Otherwise we have to measure from this place or we have to measure from this place. Now we are measuring from C. So using this diagram we can prove another formula which is called M magnification, right? Magnification is nothing but ratio of size of image divided by size of object, and which should be equal to V by U. So if you take these two triangle ABC and A dash B dash C, we formed this equation. So if you bring A dash B dash here and if you bring AB at the denominator, then A dash B dash divided by AB become B dash C divided by BC. B dash C is nothing, your V, and BC is nothing, U, right? And that's what we wanted. A dash B dash, because A dash B dash is length of image and it is on the downward side of the principal axis, so it would be sign would be treated as negative. So we will say minus y2 is size of the image divided by y1 size of the object. B dash C is a positive because it's of the direction of ray, so we will say V, okay, and U would be negative, so we will say minus U. So y2 y1, which is your M, is equal to V by U. Alright. So guys, again here, if you remember the formula, you need to know that somehow you have to find relation between this size, ratio between this and this, which was very obvious that if you take these two triangles and they are similar triangles, one of them has V, one of them has U, and both sides, so pretty straightforward. Okay, now I think we are left with one more formula, and which is called power of a lens. So power of a lens is called 1 by F and unit is diopter. Okay, so we call P equal to 1 by F. There's no formula, I'm just saying this is how we described. What we need to know, if you put two lenses together joining each other, right, and they are thin lenses, then power of combined lenses would be P equal to P1 plus P2. Okay, and we need to put sign. Okay, so F for convex lens is positive because it is the main primary focal point is here, and F for concave lens is negative, and same sign applies for power also. And if you have to prove why P would be equal to P1 plus P2, you can use the same concept what we use for convex lens. Just let me draw. Right? So if you take like this, okay, so what we'll do, you will form image, you will have image position due to first lens, right, and we will use this 1 by V minus 1 by U equal to 1 by F1. Okay, this is, let's say, F1 and this is F2. Okay, and this is image formed by first one, but rays would be reflected to second, and final image would be, let's say, formed somewhere here. So for the second refraction, the formula which would be used would be 1 by V. This should be your V dash actually, because this is not the final V. So 1 by V minus, now for the second lens, U would be nothing but V dash. So we will say V dash equal to 1 by F2. If you sum these two, right, 1 by V minus 1 by U, these will be cancelled, equal to 1 by F1 plus 1 by F2. Okay, so it looks like if you join these two lenses, you can replace them by a single lens whose focal length should be 1 by F1 plus 1 by F2. Focal length means 1 by F equal to 1 by F1 plus 1 by F2, and as we know, P is equal to 1 by F, so P of the combined lens would be P1 plus P2. That's all about lenses. So I hope you can revise these derivations with the help of these 4 or 5 formulas, and with the concepts I talked about caveats and some milestones, and it would be easy for you guys. All right, thank you.